Okay, right now we're going to look at all the derivative rules for the inverse trig function. The first one we're going to look at, obviously, it's going to be the derivative of sine inverse, right? Sine inverse of something. And as you know, it's 1 over 1 minus u squared. And how do we get that? We will now remember all we've been doing right now. We mostly are taking the derivative of a function. So assuming like this sine inverse of something is a function, right? So which is a function, let's call this y, and this. Yeah, because remember when we were doing like when we're taking the derivative of 2x, and the 2x is a function, is like this, right? 2x is a function of y, and if we're taking the derivative of 2x, which is just y prime of, or sorry about that, we're just taking them together, and which is just like this. And the derivative of sine inverse is pretty similar to this. We're taking the derivative of this function here, but only with a little bit more things to do. Let me erase this real quick and then okay. Okay, so so to take the derivative of this one, we will have to move something around first. Because remember, an inverse function always give you an angle, right? An angle. So right now you see that y is equal to that angle. So that means the angle is y. The angle is y. So if the inverse of something is the angle y, that means that the sine of this angle is u, is that something, because the inverse is y, so that means it will reverse, vice versa. So now we have to take the derivative on both sides. We have to take the derivative of both sides. This is similar to implicit differentiation. So now let's do it in the next page. So if we are doing sine y equal u, we're taking the derivative of both sides. This will become cosine y times y prime, and u, derivative of one variable is just 1, right? Just 1, remember the rule. And so if we are solving for y prime, so then we have to move things around, which we have to define both sides by, we have to define the cosine y to the other side, right? First, now look back at here. This will give you a triangle. We will draw a triangle here, because it's saying that this angle here, we're gonna call it y, and we know that the sine of y is u. So remember that sine is opposite over hypotenuse, so which is u, hypotenuse should be 1 because this is u over 1, right? So see that, opposite over hypotenuse. Okay, now let me erase that really quick. Okay, I'll put this u back here. Okay, now since y prime here is 1 over the cosine of y, but we don't know the cosine of y yet because we only know the sine of y, the sine of this angle, but we don't know the cosine of this angle. So how to find it? We have to use some trig identities, or simply Pythagorean theorem, because we remember that the hypotenuse square is equal to a square plus b square, right? So let's assume this is a, and we have to look for b in order to find the cosine of y. So we're just moving around. This will be just h square minus a square and equal b square, but then we will take the square root of this one, so we equal b. Now just plug in the numbers. Remember, a square is just u, so u square, and h square is just 1, so 1 minus u square. So what happened is after using Pythagorean theorem, we find that the length of this sine here, the adjacent sine, is just 1 minus u square. Now we are able to find y prime, right? Because y prime is just 1 over the cosine of y. What is the cosine of y? Cosine of y is adjacent over hypotenuse, which is adjacent over hypotenuse. So will just be this one. The cosine will be this one. So if 1 over cosine, which is 1 minus u square. So now look at this. This one doesn't look familiar, which is exactly the same as this one. So that's how we find the sine inverse of something. That's how you derive it. We first using kind of implicit differentiation, and then we use a triangle and Pythagorean theorem. So let's derive another one really quick. Okay. Okay, we can derive this time. Remember, let's derive the tangent, right? Tangent inverse of something, and that is just 1 over 1 plus x squared. So same thing like before, we say that the function is equal to tangent inverse of something. So which mean the tangent of y is that something, u. And now we will take the derivative of both sides, and the tangent, the derivative of tangent y, it's using the chain rule here. Kind of like the tangent, it will be secant square y times, remember, since we're looking for y prime, so the derivative of y is not 1, it's y prime. And then the derivative of u of this something, this variable, it's just 1. So after that, y prime would just be 1 over secant square y, which is cosine square y. right? So the y prime will be cosine square y. Alright, now, but we have to write, we cannot use y. We have to write it in terms of the variable, the u. So that's why we will look at the triangle. We look at the triangle, and remember the angle is y. And from the problem here, we initially knows here. We knows the tangent of y. The tangent of that angle is u. Okay, that's what we know from the original problem. So now remember that tangent, it's opposite over adjacent. This is an O. Opposite over adjacent, so which means the opposite signs here, opposite u over adjacent, so adjacent will be 1. So which means the hypotenuse will be just 1 plus u square. Is it square? Hold on. It will be just no, it will be this. So that's the hypotenuse. Okay, I'm gonna rewrite that because it looks really bad right here. Or okay, so be square, but with this. Okay, so now we figure out all this hypotenuse and all the other sign, the opposite sign and adjacent sign. So now we will look back at here and look at what y prime is equal to. Y prime is equal to cosine square y. So now we find the cosine of y. The cosine of y is equal to what? The cosine, remember, it's adjacent over hypotenuse. Adjacent over hypotenuse, which is 1 plus u squared. But y prime is equal to cosine square y, which is 2 of them. So if we square this, if we square the cosine, the final answer will become 1 over 1 plus u squared. And in this case, we derive the derivative of tangent inverse. See, that's how we got it. Hopefully this is not really confusing because I know I'm not explaining so well. So all the other one, we would for all the other inverse function, we derive them like this way. So for all the other function, we derive them this way. Let's do this again. So we will write it as a function. We'll express the inverse trig as a function, and then we use implicit differentiation. Then we will write it as differently. We will change the inverse into, we express this. We're just saying that since the inverse of this number is y is an angle here, so that means the tangent of this angle will be this ratio. Then from here on, we will take the derivative of both sides, and and then we solve for y prime, and whatever we get, if we get anything like that, we'll use the triangle. We use the triangle to figure out those ratio here.